Hi KCET 2025 aspirants, I hope all of you are preparing really well for your exam, and in today's video we are going to solve top 30 questions from one of the very high weightage topic, that is chemical kinetics. You can easily expect 3 to 5 questions from this particular chapter, so let's solve it. Try solving with me, and whichever questions you get doubt you can put in the comment section. Okay, so now coming to the first question here, that is, just a minute, yes. So higher order reactions greater than 3 are rare due to. So that is because of what? Low probability of simultaneous collisions of all the reacting species. Okay, so according to collision theory, reaction can take place when the elements will collide with each other, right, with a perfect energy and proper orientation. So more than 3 molecules colliding with proper energy and proper orientation is very less probable, and that is why molecularity or higher order reactions greater than 3 are rare. Next, just a minute. Now let us see the next question here. Half-life of a reaction is found to be inversely proportional to the fifth power of its initial concentration. The order of the reaction is. So if you remember half-life formula, okay, half-life is inversely proportional to 1 by A naught, okay, 1 by A naught to the power of n minus 1. Okay, now I can say that it is proportional to fifth power. According to question, the half-life of a reaction is proportional to fifth power of its initial concentration. So I can equate this one. N minus 1 is equal to 5, so n will be equal to 6. So I can say that the answer for this question will be 6. Next, the rate constants K1 and K2 for 2 different reactions are given. The temperature at which K1 will be equal to K2. So I want a temperature where K1 will be equal to K2, right? So I will substitute the values here. 10 to the power of 16 into 2000 by T will be equal to 10 to the power of 15 into e to the power of minus 1000 by T. Now I will divide this one. I will get 10 here, and this side if I divide this one, and here e to the power of minus 1000 by T divided by e to the power of minus 2000 by T. Now this goes up, so I will get e to the power of 1000 by T. So 10 is equal to e to the power of 1000 by T. Now if I take ln on both sides, so I will get ln of 10 is equal to 1000 by T. Okay, now to convert this one into log, what I can do, 2.303 log 10 is equal to 1000 by T, right? Log 10 is 1, so what will be the value of T? 1000 by 2.303. So that is your option number A, right? Next, which one of the following does not represent an Arrhenius equation? So you know Arrhenius equation, K equal to A into e to the power of minus EA by RT. Here it is given positive, so it does not represent. Next, the rate constant of a first order reaction is K. The time required for 99% of the reaction is given by. Okay, so you want time required to complete 99.99%, right? So 2.303 by K log of 100 by 99% is completed, means rest will be 1. So 10 to the power of 2 I can write, 2 will be multiplied here. So 4.606 by K, that is equal to T. So that is your option number A. Okay. Next, the units of rate constant for nth order reaction. So here the options are little bit, I think, not correct, but I will be telling you it is moles to the power of 1 minus n liter n minus 1 second inverse. Okay, so moles 1 minus n, I don't have any option with that. So yes, this is there, 1 minus n, and this liter is n minus 1. So none of the options here are correct, but this has to be the answer. Okay, so please write down this one. Next, consider a reaction Ag plus BH gives you product. When the concentration of G and H are doubled, the rate has increased by 8 times. Okay, if I double the concentration of G and H, the reaction has increased by 8 times. So I can write rate is equal to K into concentration of G to the power of X and H to the power of Y. Okay, now if the concentration of, so what does it tell, the first one? 8R if I'll get if I double both the concentration. Okay, that's the first thing. Next, if the concentration of G is doubled while keeping the concentration of H constant, then the rate is doubled. So rate will be double if I only concentration of G is doubled, okay, and H is kept constant. Okay, now if I solve these two, so what I can say is, see, total when I double both of them, I am getting the rate is increasing by 2 times. If I am doubling alone this one, the rate is becoming 2 times, right, double. So total I want 8, so the means when this one is double, it should become 4 times, and here when it is doubling, it is becoming 2 times. So 4 into 2 I'll get 8. So this Y must be a second order, X must be 1 order. So the order of G should be 1 and H should be 2, and that is option number B. Next, a balanced chemical equation never gives a true picture of how reaction takes place. A sequence of elementary reactions take place to give the products from the reactants. Yes. So balanced reaction is a final reaction, right? We don't know anything about the elementary steps in the reaction. So that is why a balanced reaction can never tell you about how a reaction will take place, because a sequence of elementary reactions takes place here. So both A and R are true, and A is the correct, R is the explanation. Rate constant is given, half-life we have to find out. So this is direct formula, T half is equal to 0.693 by K value is 1.5 into 10 to the power of minus 6. This one I am rounding it off to 7, this one I am rounding it off to 1.4 into 10 to the power of 6. So I will get 0.5 into 10 to the power of 6. Now see, this is 1.5, but I have rounded it off to 1.4. So the value will definitely be, or I can write like this, 5 into 10 to the power of 5, right? So now I can say the value will be less than 5. Okay, so you can find here the value less than 5, just nearer to 5 is your option number A. Next, let us see the next question here. A reaction, so this question is like this, 2A plus B, okay, is in first order with respect to A and second order with respect to B. The initial concentrations of A and B are respectively C0 and 2C0. At 30 minutes, the concentration of C is changed to C0 by 4. The rate at 30 minutes is. So first of all, let us write down the reaction. Suppose it is 2A plus B, okay, gives me C plus D, right? So now what I have here is, I can write down 2, initial concentration is C0, right? So let me write down this one, this is C0 and this is 2C0. Now what will happen here, suppose 2x amount has reacted. Now here how much it will react? X amount will react. Now 2 moles are giving you 1 mole, so 2x will give you x and this is x. So after 30 minutes the concentration of C is C, so this is after 30 minutes, okay. So I can say that x from here equal to C0 by 4. Then what is the concentration of A here? That is C0 minus 2 into C0 by 4. So that is C0 by 2 I will get. What is the concentration of B here? B equal to 2C0 minus C0 by 4. 4 to the 8 minus 1, 7C0 by 4. Then I have rate equal to K into A into B square, right, according to the given equation. So I will substitute K into A0 value is how much? C0 by 2 and B value is 7 C0 by 4. So 49 C0 cube by 32, right? So that is your option number C, okay. Next, if the initial concentration of a first order reaction is given to you 1 mole, its concentration after 30 seconds, 35 seconds is. So we have this formula, Kt equal to 2.303 log of A0 by A, right, for first order reaction. So I will put K value will be 0.693 by T half, we know that is 70. Time question asked here is 35 seconds. 2.303 log of A0 value, let me take at 1 and I have to find this A value, right. So let us do the quick calculation. Here I have 2. Then I can put everything 0.693 and if I just take 2.3, that is 4.6. Okay, 4.6 equal to log of 1 by A, right? Now what I can do, this one 0.693, then I have 35 ones are 35 twos are, and I multiplied 606. Okay, fine. So I have what rounding off I can do here is I can take this one as 0.7 and this one I can take as 4.6 suppose. Okay, that is equal to log of, I will write it as log of a to the power of minus 1. Now minus 1 will come here, so 7 by 46 minus 7 by 46 is equal to log of a. Okay, now if I solve 7 by 46, how much I will get, right? So 1, 46 ones are 10 minus 6, 4, 6 minus 4, 2, again this one 24. So I can say 5 6 are 30, 5 4s are, so 5, right? Yeah, 0.15. So I will get minus 0.15 is equal to log of a. Then what will be the value of a? A will be equal to 10 to the power of minus 0.15. I can write it as minus 1 into 10 to the power of 0.85, right? Now this is 10 to the power of minus 1 and 10 to the power of 0.85, that is log 7 value. So I will get something around 0.70. So my answer for this question will be option number D. Next, the half-life period of a zeroth order reaction is 100 minutes. The time required for 80% completion of this reaction is. Okay, so if you see for zeroth order reaction, I have A naught minus A is equal to K into T, and for T half is equal to A naught by 2K, right? So what will be the value of K here? A naught by 2 into 100, because half life is here what, 100 minutes, so I got this value. So now let me substitute A naught minus what is A. 80% reaction is completed, so how much will be left? 20%, right? So 80% of, yes, so 20% of A naught is equal to K value is again A naught by 200 into the time. So I will get 80 by 100 A naught is equal to A naught by 200 into T. So I can just cancel this one. So I will get 160 minutes. Correct answer will be option number C. Next, for the reaction NO2 plus CO, CO2, NO2, the rate is equal to K into NO2 whole square, and it does not depend on the concentration of CO. The rate is dependent on CO because, independent of CO, because CO is involved in the fast step but not in the rate determining step. Yes, that is correct. In the rate determining step, CO is not involved and the rate of a reaction is determined by the rate determining step. Since CO is not there, so in the rate equation also CO will not be there. Next, the rate of a reaction is increased by 4 times when the temperature is changed from 293 to 313 Kelvin. The energy of activation of the reaction. So we have this, what I'll say, Arrhenius equation, log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 by T1 into T2. So now log K2 by K1 will be log 4, right, because it is increasing by 4 times. EA value I have to calculate. 2.303 into R is 19.1. So please remember this value, it will help you in calculation. T2 minus T1, if you see 293 and this is 20 divided by 293, I am rounding it off to 290, and 313 I am rounding it off to 300. Okay, now I will do the calculation. 19.1 also I am rounding it off to 2. So this will get cancelled. So log 4 is 0.602 into 29, okay, 290 into 300 is equal to activation energy. So if I multiply this, you will get the value of activation energy as 52.8 something. Clear? Next question, we have been given as XA plus YB gives ZC is a chemical reaction in which minus dA by dt equal to minus dB by dt equal to 1.5 dC by dt. You have to find the values of X, Y and Z respectively. So now if you see, I can write this one like this, minus dA by dt, okay, equal to minus dB by dt is equal to 1.5 can be written as 3 by 2 into dC by dt. Okay, now we have, suppose I connect this one, minus dA by dt is equal to 3 by 2 of dB by dt. Now what will happen, this 3 can be taken denominator here, so I can write minus 1 by 3 dA by dt is equal to 1 by 2 into dB by dt, right? And dA by dt is equal to dB by dt, so I can also write minus dB by dt will be equal to also 1 by 3. Okay, so what will be equation, because these two are equal, so this one will also be equal to this one. So X will be 3, Y will also be 3 and Z will be 2. So 3, 3, 2, that is in option number B. Okay. So students, now let us see the next question here. So this is your rate determination, order determination question. So the data given below is for the reaction of NO and Cl2 to form NOCl at 295 Kelvin, and you have to find the rate law. So first of all, I want to find the order with respect to NO. So Cl2 should be constant, right? So I will keep these two constant, and if I see here, what I am doing exactly, I am increasing the concentration by 3 times, and you can see that the rate has increased by 9 times. That means with respect to NO, it is second order reaction. So I have only one option with that, so option number B. But let us see for Cl also. So if I want to understand the rate with respect to Cl2, NO should be constant, right? So here NO should be constant. Here I am tripling the concentration, rate is also becoming triple, so it is a first order reaction. So with respect to Cl2 first order, with respect to NO second order. Okay. Next, the reaction A to B follows first order kinetics. The time taken for 0.8 mole of A to produce 0.6 mole of B is 1 hour. What is the time taken for the conversion of 0.9 mole of A to produce 0.6575 mole of B? Now you see here, for first order reaction we have this formula, KT equal to, or we are talking about time, right? So let me just write down, time equal to 2.303 by K log of A naught by A, right? Now for this is the same reaction, but we have only changed the initial concentration and final concentration. So in case 1, okay, so what is the value of log of A naught by A? What is this value? 0.8 mole of A to produce 0.6 mole of B, right? So it is 8 by 6. If I just see 8 by 6, it is 4 by 3, right? So what I will get this value, 3 ones are 3, then 1.33 I will get. Now similarly for the second case, if I take log A naught by A value, okay, that will be equal to 0.9 divided by 0.675. Now this ratio is also 1.33. Now that means this part is same for both the reactions and K value is constant. So time taken will also be equal. So the time value here will be 1 hour. Next, the reaction 2SO2 plus O2 gives 2SO3 is carried out in a 1 decimeter cube vessel and 2 decimeter cube vessel separately. The ratio of the reaction velocities will be, okay. So now here you can see that I have this reaction K equal to, rate is equal to K into SO2 whole square and O2. Okay, this is the reaction. Now what is happening, you are when you are carrying out in a 2 decimeter cube, the concentration will become by half. So rate dash will be equal to K into SO2 by 2 whole cube and O2 by 2 square. O2 by 2 and SO2 by 2 square. So I will get here 1 by 8 into K into SO2 square O2. Okay, this is R dash. Now what we have to find, the ratio of reaction velocities will be. So if I just take R by R dash, okay, so I will get here 8:1. Okay, so the correct answer for this question will be option number D. Next, half-life of a substance A following first order kinetics is 5 days. Okay, so means in 5 days the compound concentration becomes half. Starting from 100 gram of A, amount left after 15 days. So I have 100 gram of A, after 5 days it will become 50, after 5 days it will become 25, after next 5 days it will become 12.5. So the concentration after 15 days will be 12.5. Next, T4 can be taken as the time taken for the concentration of a reactant to drop to 3/4 of its initial value. If the rate constant for the first order reaction is K, then what is T1/4? So we have this formula, K equal to 2.303 by T log of A naught by A, right? So I want to calculate T1/4, right? That is 2.303 by T log of, by K, okay, log of, so the drop to 3/4 of its initial value, right? So 1/3/4, that means it will become 4/3. So 2.303 by K log of 4/3. Okay, now I can solve log 4/3, very easy. Log 4/3 is equal to what? Log 4 minus log 3, right? Log 4 is 0.602 and this one is 0.478. So if I subtract, 12 minus 8 will be 4, 9 minus 7 will be 2, 5 minus 4 will be 1, 0.12 I will get. So I can see 2.303 by K into 0.124. Okay, so now if you solve this, if you multiply this one, we will get here. So you can see, like, just let me take 12 and multiply. 12 3s are 36, 3, 12 3s are 36, then 12 2s are 24 plus 3, 27. Okay, and I have here, I've just taken 5 decimal places, 1 2 3 4 5, so 0.27 something you will get. So the nearest answer here will be 0.29. Next, in the reaction A plus 2B gives 6C plus 2D, the initial rate is given. What will be the value of dB by dt? Okay, so if I write the differential equation here, minus 1/2 of dB by dt, okay, will be equal to minus dA by dt. Okay, so the question, in the question, dA by dt value is given. You have to find the dB by dt. So dB by dt is equal to 2 times of minus dA by dt. So that will be equal to 2 times of 2.26 into 10 to the power of minus 2. So it will be 5.2 into 10 to the power of minus 2. Okay, so that is your option number C. Next, for the reaction, this one, the correct relation between K1, K2 and K3. This is a good question here. So you see, minus dA by dt, dB by dt, dC by dt, the values are given. Okay, so if I want to solve according to this reaction, okay, so let me solve on this only. According to this reaction, I can say that minus 1/2 of dA by dt, okay, will be equal to minus dB by dt equal to 1/3 into dC by dt, right? There will be no minus here because it is on the product side. Okay, now dA by dt equal to what? Minus 1/2 K1 into A square. Okay, then dB by dt equal to K2 into A square, and 1/3 dC by dt equal to K3 into A square. Okay, now A square will be cancelled in all the cases. So 1/2 of K1 equal to K2 equal to 1/3 into K3. Okay, so what is the relation here? You can see K1/2 is equal to K2 equal to K3/3. So the correct answer for this question will be option number D. Next, decomposition of NH4NO2 into N2 and H2O is a first order reaction. Which of the following graph is correct? Okay, so if it is a first order reaction, you know that the rate, you have NH4NO2 concentration, right? So NH4NO2 concentration will definitely decrease because it is a reactant. So this cannot be there, this cannot be there. Now there is a decrease here also, there is a decrease here also. But if you see the first order reaction, what is the formula we have? K equal to, right? K equal to, sorry, we write here like this, just a minute, okay. We have Kt equal to ln into A naught by A, right? Now if I just remove the ln values, then I will get e to the power of Kt is equal to A naught by A, right? And I can write A equal to A naught into e to the power of minus Kt. Right. So what is happening here? You can see there is a decrease in the concentration but exponential decrease. So this is a linear decrease, this is an exponential decrease. So that is why option number D is the correct answer here. Okay, next again we have to predict the order of the reaction. So let us see first with respect to A2. So B2 should be constant. I will consider these two reactions. So A2 concentration is doubling, rate is also doubling. So A equal to 1. So I have only one option with A equal to 1. Okay. Next if you see B, means I want to keep A2 constant. So these two I have to keep constant, and here you see this is doubling. So this one will also double. So with respect to B also it is 1. So first order option number A. Next we see here, okay, the rate of the reactions of A2 and B2 follows the given equation. The following data were observed. Okay, fine. Now if you see here, first of all, when B2 is constant, okay, A2 concentration is doubled and here also it is doubled, right? So I can say that if I have rate equal to K into A2 into B2. Okay, so now what happens when this one is doubling, rate is also doubling. So with respect to A2 it is 1. Now with respect to B2, if I want to calculate and I want to keep A2 constant, so here it is doubling, here also doubling. So that means with respect to this one it is also first order. Okay, now the question, if I want to write that, you have to write what? The following data was observed, the value of rate constant. Okay, fine. So I can write like this, rate is equal to, right, rate is equal to minus dA2 by dt equal to minus dB2 by dt, okay, is equal to 1 by 2 of dAB by dt. Right. So this is because in the question we are talking about the appearance of AB or with related to AB. So what is rate here? 1 by 2 of dAB by dt, right? So first of all, what I can calculate here is, we can do here, I will put the values. Rate, the formation of this one, rate is equal to 1 by 2 of dAB by dt, okay, is equal to K is there, that I have to find out, and then I have A2 value and B2 value. So 0.1, 0.1, so I can write 10 to the power of minus 2, right? And here I can write this one as 2.5, 2.5 into 10 to the power of minus 4 divided by 2 divided by 10 to the power of minus 2. So I'll get 1.25 into 10 to the power of minus 2. Okay, so that is your option number C. Once again I want to repeat this part. So in place of rate, I am writing the value. Rate is also equal to 1 by 2 dAB by dt, right? So I wrote this one, then equal to K into A2 concentration, how much? So it is like this. 1 second. Oh, sorry. Fine. I'll just repeat once again. See, I got rate equal to K into A2 to the n B2, right? In place of rate, I can write minus 1 by 2, sorry, plus 1 by 2 dAB by dt. Why I am doing this one? Because here it is AB which is given in the question. Then A2 concentration here is 0.1, B concentration is 0.1. Now AB by B, this one is 2.5 into 10 to the power of minus 4, then 1 by 2 into 10 to the power of, this is also minus 2 equal to K. So I'll get 1.25 into 10 to the power of minus 2. Okay, so that is how the answer will be option number C. Next, in the reaction A gives B plus C, the rate constant is given to you. If we start with 1 m of A and the concentration of A and B after 10 minutes are respectively. Okay, 1 second. Yes, in the reaction A gives you B plus C, the rate constant is given. Okay, so we have this formula, that is K equal to, it is a zeroth order reaction, you can see from the unit. So zeroth order reaction, that is A naught minus A. Okay, so what is the K value? 10 to the power of minus 3 into time value is how much? After 10 minutes. So you must convert it into seconds, because this is also in seconds. So I'll convert it into seconds. A naught is 1 minus A value. Okay, so if I solve this, this is 600 into 10 to the power of minus 3, means that is 0.6. So A value will be 0.4, right? So concentration of A will be 0.4 and concentration of B will be 0.6. So answer will be option number C. Okay, next, the activation energy of the reaction A plus B gives you C plus D plus 38 kilocalorie is 20 kilocalorie. What would be the activation energy of the following reaction? So you can see that 38 kilojoule or kilocalorie of energy is released in the reaction, right? So how much it will be? So A plus B gives me C plus D. Okay, now what happens? Okay, this value comes out to be 38. Okay, 38 kilocalorie. Now the activation energy for this one is 20 kilocalorie. Okay, now the question is asked that for the reaction C plus D gives A plus B, what is the activation energy? That is the total value of this one. So 38 plus 20 will be your 58. So the correct answer will be option number D here. Okay, next question, the temperature coefficient of a reaction is the ratio of the rate constant differing by 10 degrees Celsius, preferably 298 and 308. Okay, so if you have the, I can say temperature coefficient is basically K at T plus 10 divided by K at T. Okay, and preferably we consider room temperature and 10 degree above room temperature. So the correct answer will be option number D. Next, a hypothetical reaction A2 plus B2 gives 2AB follows a mechanism given below. Order of the overall reaction by RDS method is. Okay, so now see, the rate is always determined by the slowest step, right? So I can write rate is equal to K into A into B2. Okay, now what is the thing here, that in the final reaction there is nowhere A, right? There is nowhere A mentioned. So this is an intermediate. So A must be represented in those terms which is given in the reaction. So from the first reaction, it is an equilibrium reaction, right? So I can write K equilibrium is equal to product concentration divided by reactant concentration. Okay, so from here I can write A concentration is equal to K equilibrium into A2 its root over. Okay, now if this is there, this I can substitute here, so that will become K, and here it is K equilibrium into A2 1 by 2 into B2. Okay, now what will happen, this is 1 by 2, so this together will be considered as one constant K dash, A2 to the power of 1 by 2 and B2. Okay, so it is 1 by 2 plus 1, I will get 3 by 2. So the correct answer for this question will be option number C. Okay, Okay, so students, these were the top 30 questions from chemical kinetics. I hope you have solved all the questions, and yes, if you have any doubt in any question, please put down in the comment section. I will definitely address to it. So do not worry, any doubt you can put down, and do not forget to subscribe our channel. Chemical kinetics is a very high weightage topic, so please prepare more questions. These questions, if you have any doubt, you can put doubts. Okay, so that's all students, all the very best, and thank you for watching.